Now, let's go through like one of the corner detection algorithm. And the idea here is we'll try to find these corners where different edges are actually meeting. And this is from this very famous paper. Okay, so it's called like Harris corner detector. And let's go over like the basic idea of this algorithm. So in this algorithm, what we want to do is we want to first of all not look at the global picture. We'll look at small windows or small regions, and we try to find out whether in this small vicinity or this in smaller region, whether corners are present or not. And as we discussed earlier, like corners could be interesting points. And of course, not the only interesting point. There could be a lot of other different ways to define interesting points, but this is one of the variation. Right? So what it tries to do is it tries to find out these corners in small windows. And what this algorithm does, you operate on these small patches and you try to shift this patch in the image, okay, in various different directions. And the idea is if you change the location of this patch and the intensity is actually not changing, then it's not a corner. Okay. And if the intensity is changing, intensity changing means like you're trying to match actually that patch with the image patch. If the intensity doesn't change, it's not an interesting point or it's not a corner. But if the intensity will change, it means there will be a corner. Okay, so let's go through these simple examples to understand this better. Okay, so this is your location. Now, what you can do is you can just count the intensity of all the pixels which are inside this box. Right, all of these are black pixels, so it will be 255 if we compute the average value, or you can select 0 if 0 is black. Yeah, if 0 is black. Okay, so the average intensity at this location is 0. Now, if you slightly move this towards left, towards right, or top or bottom in any direction, that intensity will still remains 0 because the pixel value is not changing, which means that your surface is kind of flat and there's no change in any direction, and it's not a corner. The other way could be, let's consider like this patch on this location. Okay, if you move your filter in top down direction, again you can see that there will be no change, right? Because the number of white pixels will not change if you move this towards the top, or if you move this towards the bottom. And similarly, the black pixels are not going to change. So the average intensity will still remains the same, although it's an edge, but it's not a corner. Okay. Now, if you put this patch on this corner right over here, then it doesn't matter like in which direction you move your patch. You will always observe a change in intensity, right? For example, if you go towards like this direction, which is left top, then you can see that number of white pixels will increase and number of black pixels will reduce, which means your average intensity is going to increase. And if you, let's say, go towards right bottom in this direction, then again, your black pixels are going to increase, white pixels are going to reduce inside that region. So your intensity again will change, it will drop. So it doesn't matter which direction you go, your intensity is always changing. So this is a very, very clean technique, right? Very simple algorithm. And you can identify like any corners you have present in your input image. Okay, so let's see like how exactly this is done. Of course, that was like a high level idea. We need like a much more complex algorithm for that. And I will have to select this. This is like the most complex algorithm we are going to study in this course. And of course, we are not going to go into detail because this algorithm itself will take, I think, a couple of lectures if we try to do that. Okay, but I will tell you like which part you should focus on, which part you can ignore. I think that will be useful for you to go through this. So the basic step, what we can do is we can just perform template matching. And template matching you have seen a lot in this course. Okay. So the idea is you create template of these corners, something like this. Okay, so this is a template of a corner where you will see like a corner like this. And if you put this patch or this kernel on your input image, then if you will have a corner like this, it will be able to identify that because that's the pattern we are looking for. Okay. Similarly, this particular pattern template here, it will look for corners which are in this direction. Right. Similarly, you can create like other templates, like you can just keep rotating these values. And whenever you will have a matching corner, these templates will be able to match it. Okay, but this is like a very crude algorithm. And of course, we don't use this because this is like a lot of limitations as well. It is only considering like some discrete values, right? Of course, you can make it like slightly bigger and make it more smooth, but still it will be discrete. Okay, so that's fine. So the other thing is like the summation of this filter should be 0, which I think you know by now. It's kind of trying to normalize. And if you have different intensities in your input image, then you don't want them to be like different. You want the response always to be the same number to be able to identify whether there's a corner or not.